Okay, so today's problem string is on fraction subtraction. So we've talked about adding fractions using the clock and money models. Now we're going to talk about subtracting, which looks just a little bit different, but it's the same concept. We're still going to be looking at these fractions and using time or money to find a common denominator, essentially, or an equivalent fraction. So what you're going to focus on today is what the best model would be. And for these examples, if there's more than one, we're just going to go ahead and use both just to kind of demonstrate what that would look like so that you can use which one you feel most comfortable with, okay? So in the first problem, 1/2 minus 1/4, I want you to take a minute to think which would be the best model to use, okay? You might want to take a look at your notes. So let's think about it. So can I represent 1/2 on a clock? Well, absolutely. A clock is out of 60ths, right? So 1/2 would be 30/60ths, right? So I can show 1/2, right? And if I wanted to demonstrate that, I would highlight using two different colors, just like we did with our adding, okay? And now, can I represent 1/4? Well, can I break a clock up into fourths? Absolutely. So it's already in half, and half of half is a fourth. As you can see here, this is a fourth, this is a fourth, okay? So on and so forth. And 1/4, if I'm taking that away, so before we were adding, and remember how we were shading in because we were adding on? Well, we're not doing that now. We're taking it away. So what we're actually going to do is we are going to cross off what's not being used. And since this is a fourth, right over here, this is a fourth, we're just going to cross one of these out, okay? And 1/4, how much time is represented by a fourth of an hour? And as we look at that, we can see that it's 15 minutes out of 60, okay? And that would leave us with what's left over. And what's left over is right here, okay? Which is 15/60ths. Now, if we want to break this down even further, we can. How can we do that? We can simplify it. So 30/60ths minus 15/60ths equals 15/60ths, or 1/4, okay? So there is the clock model, okay? So as you can see, oops, I'm moving too much here. As you can see, the clock model does work. Just gonna move this over. Now let's try and see if the money model works. Okay, you might already have that answer in your head. Can we represent a half of a dollar? Half of a dollar. Well, absolutely. So I see half of a dollar here, right? And I'm gonna go ahead and shade it in. I'll just be consistent with my coloring, okay? So I have a $1/2. All right, beautiful. And I wanna take away a fourth of a dollar. So similarly, I'm going to divide this up one more time so that I can see the fourths, and I'm going to take a fourth away. And I know that a fourth of a dollar is 25 cents, so I'm going to go ahead and take that away. So just to show it again, I'm going to say half of a dollar is 50/100ths, or I can even go as far as saying 50 cents, right? Because I feel comfortable with money. And I subtracted a fourth of a dollar, which is 25/100ths, okay, or 25/100ths written as a decimal. And 50 cents minus 25 cents is 25 cents. And 50 minus 25 is 25, right? And that equals 1/4, okay? So I was able to get the same answer with two different models, okay? So I can now answer 1/2 minus 1/4 is 1/4, okay? And then I'm gonna go ahead and just explain why. So I'm just gonna say either or both work because you can divide models evenly, okay? They don't really give you a lot of room to do that, but explaining our thinking is crucial. All right, let's go ahead and do the next one. So remember, these problem strings build upon each other. So 3/4 minus 1/5. Let's take a look at these two models really quickly, and let's think which model would work best. So I know that I can break both a clock and a money model up into fourths. So 3/4 I can easily show, just like I did up here. I broke them up into fourths. That's easy. But a fifth, this one's gonna take some thinking. Can I find a fifth of an hour? Well, absolutely. okay? 1/5 of an hour. So when I multiply some number by 5, I get 60. Well, I know that 12 times 5 is 60, but I don't know that I can really show very well 12 minutes on a clock very consistently. So if this is 10, I'd have to go a little bit over. Yeah, I don't know if that's efficient. I want to be efficient. So I think with money, 1/5 of a dollar, do you remember how much that is? 1/5 of a dollar. So some number times 5 equals 100. Well, we talked about when we had 2 dimes, we had 1/5 of a dollar. 2/10 is the same as 1/5, right? So 1/5 is equal to 20 cents. So I'm going to say the money model is going to be the best option here. So let's start by breaking this dollar up into fourths, okay? Into fourths, okay? And we'll go ahead and we'll shade in what we started with. So you have 3/4 of a dollar. 3/4 of a dollar, okay? Which is the same as 75/100ths or 75 cents if you want to work that way. Now remember, I'm going to be subtracting. So I'm going to be subtracting 1/5 of a dollar, which we already kind of walked through this together. It's 20 hundredths or 20 cents, okay? So I'm just going to count here. So I know that each one of these columns has 5 cents in it. So I'm just going to say 5, 10, 15, 20, and I'm going to go ahead and cross out 20 cents, okay? So I know that this area here is 50 cents, a half dollar, right? And then I have 1, 2, 3, 4, 5 cents left. So 75 minus 20 is 55/100ths, okay? Is this simplified? No, it is not. 55/100ths is the same as 11. What do you multiply by 5 to get 100? Think about it. 5 times 10 is 50. 5 times 20 is 100. So 11/20ths. So 3/4 minus 1/5 is 11/20ths. And in this case, we're going to say the money model, because you can divide evenly, okay? It's easy to represent, all right? Okay, so far so good. Let's do the last one. I'm gonna let you try this one on your own. So go ahead and pause the video, and then when you're done, you can just kind of watch me walk through it. All right, so hopefully you've paused it and you're not listening to me right now. And if you are listening to me now, hopefully you're just coming back. I'm gonna go ahead and break this up into fourths again. And I'm gonna do the same thing I just did because I have 3/4, right? And I'm starting with the same amount. So I'm starting with my 75/100ths. And in this case, I'm just going to mix it up, and I'm going to write 75 cents because I want us to be able to interpret both ways, okay? But this time I have 2/5. Well, it's a problem string, so I'm going to use my previous problem, 1/5. Knowing that that's 20 cents or 20 hundredths, right? Over here I identified that. I have 2 of those now. So if I have 2 20 hundredths, then how many do I have? Well, you are correct if you said 40 hundredths. Okay, so I'm going to subtract these two, and I'm going to say minus 40 cents. Okay, now I need to represent this. So I know that this region over here, this is 25, okay, 25 hundredths. So I know for sure I'll be crossing this off because I'm definitely not going to be using the 25 hundredths. And then I know that these are in increments. Each of these columns within this bracket are increments of 5 or 10 if I want to go all the way down. So I have 25, right, so far. So here's 35, 45, and 50. That's one way of doing it, which is kind of confusing for me to look at. So I'm just going to go by 5s. So I know that if I did the whole entire, this whole entire section, it would be another 25, which would get me 25 and 25 is 50. So I'm not going to do that either. I'm just going to count by 5. So I have 35, 45, I'm sorry, 30, 35, 40. Okay, so I cross these two off. And what I have left is going to be the 25 cents here and then another 10 cents, which would be 35 cents or 35/100ths, okay? Hopefully this makes sense as I'm walking you through it. The only purpose of showing this visually is so that you can see that you're taking away, okay? So 35/100ths is not simplified, okay? 35/100ths would be the same as 7, because 5 times 7 is 35/20ths, okay? So there you have it. And I'm gonna just go ahead and copy and paste because I have that option. The same exact reason why. Same reason why I used the previous model is why I'm using this model, okay? Except I don't need all of this. There we go. All right, hopefully this makes sense, and you are free to do the next